To start this challenge, we're going to open up a new sketch in p5.js, and we're going to start with the available window width and available window height in the create canvas parameters. To access the third dimension in p5.js, we need to specify that here in the z parameter of the create canvas. To do that, we're going to declare that WEBGL will be our reference for the third dimension. So whenever p5.js has to do some three-dimensional thing, it's going to look at WEBGL and shrug, and then WEBGL is going to take over. At the very top, we're going to declare a variable called particle. It's going to hold our object, which is a system of particles that are positioned in a grid shape, and then there's different particles that move through this volume along that grid shape. So that's what our particle system is. It may not look like a particle system, but fundamentally it's kind of acting like one, so that's why I called it that. You can call it whatever you want. So in setup, we're going to take that variable particle that we've declared, and we're going to assign to it a new instance of particles with an S, and that's going to be a function that we create that is going to make all of the stuff happen. We want to set up some global attributes for our graphics. We don't want there to be any fill necessarily. We want the stroke of these grid lines to be some color. I'm going to choose phosphorus green here. And because we're working in 3 dimensions, we want these lines to show up as 3-dimensional lines. If we make them too skinny, that's not going to happen so much. So to make that a little bit more evident, we're going to take the stroke weight up to 5. And that should be okay. You can play around with that if you want. To make this program run a little bit faster, I'm using 2D primitives instead of 3D primitives. There's less there to compute, so the program's going to operate faster, so we can have more particles in our system. If I try to do this with 3D primitives like spheres, it wouldn't hardly work. It'd just be so slow and clunky. It wouldn't be interesting at all. I'm going to use the 2Ds to speed things up. Because we're dealing in 2 dimensions, the origin may not be in the center. So it could be in the corner. So we're going to put that in the center by declaring it in rec mode and put center in all caps in the parameters there. That's everything for setup. Let's do draw. Let's set the color background to 0. And we want to translate to 0, 0, 0. It's already translated there by default. But I'm going to put this command here in case we want to move things around. It'll be there just in case. And plus you can play around with that and see what it does. So in p5.js we have this command here, rotate, and then we can assign to it some angle. What that does is it takes the canvas, which is x and y, and it rotates it in the only dimension that isn't assigned to anything, which is z. So when we rotate the canvas in p5.js, we're actually rotating it in the z, along the z-axis. So by default, rotate rotates the z. In WEBGL, we have access to all 3 axes of rotation, so we can denote that with rotate and then a capital X, Y, or Z, and that'll tell you which axis to rotate around. So we don't want to really use rotate without one of those specifications. Otherwise, it's not going to do what you want. It's going to rotate the Z, and you're going to be like, what's happening? So once we have those the space, this is the rotation of the global space. So our grid and the objects moving through it are going to be fixed in their orientation relative to one another. And then we're going to be kind of spinning around it, or it's going to look like it's moving within the volume. Either way. Once we have that, we're going to put a method in our function called update, and that's going to do all the business of making these particles move in this visualization. To do that, we're going to use the variable that we assigned the object to. We're going to use dot syntax, and we're going to call the name of the function, which in this case it's called update. That's it for draw. So now let's go down into making the function. So up there we called this function particles. Inside that function there's a method called this.update, or update, and since it's in the function we got to put the this dot there. And it's going to equal a function so that we can call it and have it do some action. So we have our blank method there, we have our blank instantiation space here where we're setting our first time variables. So we need to divide our dimensions up to make a grid, right? And if you draw a grid, how many squares are there on the x, how many squares are there on the y, and the z. So we need some variables to hold those. I'm going to have one for each of the dimensions. I'm going to call it this dot increment, increm for short. And then if it's for the x, I'll just put an x there, a y, or a z, whichever one it is. So for the X, it's going to be the width, and I'm going to have 2 divisions along the X, 2 divisions along the Y, and 2 divisions along the Z. Pretty straightforward. Now normally when I'm working with an array, I just loop through each element in the array using like for I, and then if I need a location associated with that element to print it on the screen somewhere, it has its X and Y associated with it already. That's not what I'm doing here in this case. I'm using the loops to give me the X and Y locations because those are pretty much fixed except for the Z. So I can use loops for those because those values aren't really changing. The disadvantage of that is I don't have an index value from my loop. I have to increment a variable in order to have an index value to access the elements in the array. So I need a variable for that. I'm going to call it index, easy enough to remember. And just for now, I'm going to set it to 0. Doesn't really matter, that's arbitrary. But I'm going to set it to something and I'll make it 0. Why not? So once we have the index variable, we do have a variable that changes for each of the objects that are moving through the volume. They need a location in that depth. So I'm going to have an array that holds that Z location. They're not all moving at the same speed, so I need an array for that. And they're different shapes. And then on the grid itself, in the nodes of the grid where the lines intersect, there's a shape associated there as well. So let's give it its own shape, and let's call it G shape, just to make things easy. Okay, so those are our arrays. There are 4 arrays there. So now we have to, well, first, let's do this first. Let's make a global variable for our speed. And since we're moving from positive to negative numbers, a higher speed will be negative higher number, and a minimum speed will be a lower negative number. But if I'm doing randoms, if I have these as the arguments in a random, then I'm going to put the lower number first and then the bigger number second. I'm not sure if it works like that, but that's just, my brain is telling me that's how it has to be. And let me know in a comment if it's not. So anyway, that's that. Once I have those local variables for the speeds, I need 3 loops. I need a loop for the depth. So the first thing I'm going to do is find out where am I at in this depth. And then once I'm there, I'm going to make a grid with the rows and columns. So first loop is the depth. I'm going to call it deep. And it's going to move from the furthest distance away, which is negative height. And it's going to go to the closest distance to me, which is height. And it's going to increment by that Z incrementer. We need another loop for the columns. Same way. We're going to do the left-hand side. And because I want my depth to be a lot more than the other dimensions. So I want it to be really long, like a hallway. But I want it to be like a short ceiling and short distance from wall to wall. So to do that, I'm going to divide my height and width by 2. And then my Z dimension is just going to be the full dimension times 2. I don't actually have to times 2 it because I'm using 2 height with negative height and positive height. That's 2 height. I'm going to move to from the left-hand side to the right-hand side, and I'm going to advance each step by the X incrementer. So we have 2 loops now. Let's have one more for the Y, or the rows. And this is going to be negative height divided by 2, and we're going to move to the height divided by 2, and we're going to increment by the Y incrementer. Did I say Y incrementer up here? Something in my brain is saying that I said Y here. If I did, I'm sorry. I meant X there. Sometimes I catch those things way after. All right. Now that we have our 3 loops, we'll have an object or a node associated in every spot in that volume. So now we can do our assignments to our arrays because we're going to get all the possible different combinations from inside the loop. So the very first thing I want to do is take our height, and I'm going to push into that array, into that element of the array, the height. So all of our objects that are moving through the volume are going to start at the same position, which is closest to the viewer. I'm going to push into the speed array a random speed, and that's going to be that those local variables, max and min. We're just going to plug those into the random parameters. The shape is a little tricky. In the push for that, I'm going to take the floor of a random number between 0 and 3. So it'll be 0, 1, or 2 will be the return of this. I'm going to do that for our moving shapes, and I'm going to do this for our grid node shapes right here. So just duplicate that line. That should be it for all of the variables that we have to instantiate and get starting values for. I think we're ready to do our update now. This is going to perform all the action. Very first thing in update, we want to reset the index value to -1, so that before I use any array elements, I'm going to increment the index value, and then I'm going to access the array. So at the very beginning of all the loops, I want my index value to be -1, so that when I increment it for the first time, I'll start at 0. Now we need loops again. I'm not typing these all again. Let's copy and paste. What a beautiful thing. So we're going to take all 3 of those loops. Let's copy it. We're going to go down into update right underneath index, and we're going to paste it. Then inside the 3 loops where we are declaring, or where we're assigning the arrays, let's just delete that. Leave us a nice blank open spot in the middle. I'm going to give us some space between each one of these loops because we're going to do stuff inside of each section. So inside the Z section, we're dealing with the depth now. Let's translate to that layer in the depth. So to do that, we're going to do translate, and we're going to stay at the X and Y in the center of the width and the height, and we're just going to move all the way to the back wall. Next, after the columns, now we're in the columns loop, and since we have the column value, we can draw those columns. So we're going to make a line. Our starting point for that line is going to be the column from the loop, and we're going to go to the top, which is height divided by 2. We're going to stay at that column X, and then we're going to go to the bottom, which is height divided by 2. So that's drawing our column lines. Now we're ready to go inside row. And inside row, we need to advance our index value. Let's do that first thing before we forget. So now we're on the right element. Since we're on the right element, we can adjust our Z so that our objects are moving through the volume. So we're going to grab that Z array. We're going to put this dot index in the element value. And we're going to add the speed array value with its associated index. There we go. Since we've moved that object in the volume, let's check and make sure that it's not out of bounds. For some variety, I'm going to add deep to this constraint so they'll disappear at strange times along that Z depth. Inside the condition, if it's out of bounds, let's take care of that. So let's reset the Z back to the top. So we're going to set it equal to positive height. Let's pick a new speed for this object. Let's pick a new shape. And let's do that twice because we need our shapes that are moving through the volume and our shapes that are tied to the nodes of the grid, and that's G shape. And for some variety, instead of picking just a new random shape for the grid, let's assign it to whatever shape has just been assigned a new value or has gone out of range. So if a shape goes out of range, I'm going to take its corresponding place on the grid and change its value. Just a little stylization there is all. You can do whatever you want there, kind of make it a variety, spice of life. We're outside of the condition now. We have good values, we're ready to do stuff with them. So I'm going to assign to a local variable a color. So I'm going to take the map of whatever the Z is for this object, wherever it's at in the depth. I'm going to take that value, which can be anywhere from the positive height to negative height. And now it can be a dark color to a light color as it goes from us to away from us. Let's draw our horizontal lines, or our row lines. To do that, we're going to start at the left-hand side, and we're going to use the row for our Y. We're going to go to the right-hand side, and we're going to use our row for the Y again. That's going to draw a flat line in the horizontal. All right, getting closer. Let's put a push and pop here. This is the line that is the Z. It's going to describe the Z axis. To do that, I need to translate to wherever we're at in that grid. So I'm going to use the column and the row. We're at the depth that we need to be with 0. Now I want to rotate it into the volume, negative pi, and I'm going to rotate by half a circle, a quarter, or half pi, or a quarter circle. Let's make that line a little thinner because that's how the action is happening. So we want it to look a little special. And let's change the color of it to gray. And let's draw that line. I'm going to draw it at X. I'm drawing a vertical line, and then I'm rotating it into the Z. Because I don't really have a Z coordinate that I can draw a line to, because it's X and Y. That's all you have with line. As far as I know, I don't know that it works with Z. So you can use the X and Y, just draw that where you need to, and then rotate it into the dimension that you need it to go into, which is typically the Z. The size of that line is going to be determined by one of the incrementers. I'm using Y here. They're all the same, so it doesn't matter. But if you have different incrementers, then it is going to matter. And you'll have to make the changes accordingly. So let's get outside of that pop. So now we're back in the global translation. Let's make another push and pop again so that we can work within that and then translate to where we need to. So here is where at the grid, in the depth, wherever the nodes are, that's where we're going to put a geometry. So that's what this is. So let's translate to where that node is. Let's do some rotations. You can do your rotations here. I'm not going to do them just for the sake of time. We need to know which shape to draw, so we're gonna make a determination here. Let's use a condition, and let's look at that variable that's describing the shape that it should be. 0, 1, or 2. If it's 0, then we're going to draw something. If it's not, we're going to draw something else. So let me copy this so life is easy. That made things easier. And just going to put a 1 there. Do our brackets. Drop it down. And one more else. This one's going to be the last one there. Let's make our brackets. Alright. Inside the conditions, it's empty now. Let's put stuff in there. So if this shape is a 0, let's draw a circle. And we can draw that at where we're translated presently. And let's make it be 100 in size. If it's 2, let's draw a rectangle. And if it's 1, let's draw a triangle. You can put these in any order you want. It's arbitrary. I just did it this way just to be different. So to draw a triangle, we want to draw this triangle inside whatever size square we have here. So negative 50 is going to be the top of the triangle, positive 50 is going to be the bottom, negative 50 is going to be left, positive 50 is going to be the right. Using that coordinate system, let's make some points for our triangle. So we're going to use 0 and negative 50 for the top, middle. We're going to drop down to the bottom left. We're going to move over to the bottom right. And then the triangle function, this triangle method, will complete itself because it has all the coordinates to do that. So there's a triangle. One more push and pop, because those were the geometries that describe the nodes of the grids. Here are the geometries that are moving through the volume and passing through those nodes. It's the same sort of thing, except for we have to translate to a different position and we have to draw different geometries. So let's copy this, paste it in there, and instead of translating to 0, we're going to translate the Z to wherever that geometry is in the volume. And instead of testing for G shape, we're going to test for shape, the shape array. So let's take that G off of there. And we can just draw the same kind of geometries, but we want to fill it. We want to fill it with the local variable that's holding our color. And let's make the stroke be the inverse. So we'll take 255 and subtract our color from it, and that'll give us the opposite. So I have a fair degree of confidence that I did this correctly. Let's cross our fingers. And everything looks like it's happening. It's pretty cool. Just scroll back up here so you, if you need to, pause on any of these parts. And you can look at the output while that's happening. Now it's still kind of chunky. What you can do is slow down the motion. So make these numbers smaller so the rotation is slower. Make the max and minimum speed lower so that the objects are moving more slowly. And then you can just render this very slowly. Then you could speed up the output in like a video some way.
Well, I hope you've enjoyed this challenge. If you typed along, let me know how it worked for you. If it was confusing or if it wasn't, if you learned something, I'd be really happy to hear what your thoughts are. Feed the algorithm, hit the like. If you do like this video and you want more like this, be sure you're subscribed and hit the bell to be notified. And I guess, as always, until next time, take care.